Dear students, today we're going to discuss the concept of constructing the pedal equation of a Cartesian curve. So as you can see, this is going to be the working rule. So the equation of the given curve will be of the form f of x comma y equal to 0. That means the equation is given in Cartesian form, and if such an equation is given, the following are the steps to find the pedal equation of a curve. So the step 1 would be to find the slope of the tangent to the curve dy by dx. So that is done by simply differentiating the equation of the curve and finding dy by dx. Once we have found dy by dx, in the second step, we construct the equation of the tangent to the curve using the formula y minus y equals y dash into capital X minus x, where x comma y is the point at which we find the tangent. So in this, substitute dy by dx and rewrite the equation of the given curve of the tangent to the curve in the form of ax plus by plus c equal to 0 using this equation. Once that is done, in the next step, we find the perpendicular distance from the origin to this tangent using the formula p equals modulus of c by root of a square plus b square, where c is the constant in the equation of the tangent and a and b are the coefficients of capital X and capital Y. So once we have found p using the formula p equals modulus of c by root of a square plus b square, what we do in the next step is we compare this equation with the given equation of the curve, and also we use the equation r square equals x square plus y square, which is very well known to all of us, to find the pedal equation of the given curve, eliminating all the variables other than p and r. So once again, I'll repeat the steps. The first step, given the equation of the curve, find out dy by dx. Okay, and in the second step, substitute this dy by dx, which is y dash, in the equation capital Y minus small y equals dy by dx into capital X minus small x, and rewrite it in the form of a into capital X plus b into capital Y plus c equal to 0. And then find out p using the formula modulus of c by root of a square plus b square, where c, a and b are obtained using this equation. And once we have done that, then we compare this equation or this expression with the given equation of the curve, and also substitute for x square plus y square as r square, and by eliminating all the variables other than p and r, we obtain the pedal equation of the given curve. So these are the steps involved. Now to understand this, I would like to give you a simple example. So this is a problem that we are going to solve here. So the question is, obtain the pedal equation of the given curve. Right? Now we'll start taking the equation of the curve, which is basically x square plus y square equals is 2ax. So the first step will be to find out dy by dx. So we'll differentiate this equation, which will give us, again, differentiation would be done with respect to x, and that will give me 2x plus 2y into dy by dx, which is basically y dash, and that is going to be equal to 2 into a. Right? Now this can be further rewritten in such a way that we get y dash on the left hand side and everything else on the right hand side, and that will give us, as you can see, 2 will get cancelled off everywhere, and we'll be left with y dash equal to a minus x divided by y. So this completes the first step. Now moving on to the next step, what we do in the next step is, as you can see here, we obtain this equation. We rewrite this equation in the form of y minus y equals y dash into x minus x, which will give us y minus y equals, now y dash is a minus x divided by y into capital X minus x. Now this equation now should be written in the form of, as I mentioned earlier, a into capital X plus b into capital Y plus c equal to 0. Here a, this a should not be confused with this a. Okay. Now, for that to be done, what we do is we'll cross multiply this y so that we get y into capital Y minus y square, and multiplying this a minus x with these two terms will give us a minus x into capital X, correct, minus of a minus x into x, correct. Now accordingly this can now be rewritten as a minus x into capital X, as I said, some term into x, and then if I take this term to the right hand side, minus y into capital Y is what I get, and the rest of the terms will be rewritten as they are, and that will give me plus y square minus a minus x into x equal to 0. Okay, now here as you can see, this term what I have got is what is the term corresponding to ax, so that small a will turn out to be a minus x, and the same way b will turn out to be minus y, and this would be the term c. Okay, now we'll move on to the next step, and in the next step we have to find p using the expression p equals modulus of c by root of a square plus b square. Okay, so that will give me p as, yeah, now modulus of c will give me y square plus, sorry, y square minus, it should be a minus, right? Yeah, y square minus a minus x into x is what is c, and then divided by root of a square. A square will give me a minus x the whole square, and then plus b square will give me minus y the whole square, which is simply y square. So this is the expression for p, or in other words this will be y square minus ax plus x square, correct, or divided by root of, on simplification this will give me a square minus 2ax plus x square plus y square. So this is the expression for p. Now what we are supposed to do is we'll have to compare this expression with the equation of the curve, and also use the expression r square equals x square plus y square to eliminate all the variables other than p and r. So we'll do exactly that. So now the given equation is x square plus y square equals 2ax, correct. Now if x square plus y square is 2ax, then we have p to be equal to, yeah, as you can see here we have an x square plus y square which can be substituted by 2ax, and then this will be minus ax, and this divided by root of, and here x square plus y square is 2ax, which will get cancelled off with minus 2ax, and that will just give us a square in the denominator. So this will be ultimately, as you can see, if you take 2ax minus x, that will be ax, and the denominator will be simply a, correct. Or in other words, this will give me p equals x. Now we'll have to eliminate x from this expression using the formula x square plus y square equals r square. Now x square plus y square equals r square will give me, from this equation, r square equals 2ax, right? So r square equals 2x will give me x equals r square by 2a. Okay, now using, or if I call this as equation 1 and this as equation 2, then we have, from using equation 2 in equation 1, p equals r square by 2e, or p, sorry, yeah, or I can write this as p into 2a, which is 2ap equal to r square. Now this can be called as a pedal equation because this has only p and r in it. So this is the required pedal equation of the curve. Right? Now this is a procedure to find out the pedal equation of any Cartesian curve. Now to understand this better, we'll take up one more example. Right? Now in this next example, what we do is we'll find out the pedal equation to the curve y square equals 4a into x plus a. So what is the first step? Y square equals 4a into x plus a upon differentiation will give us 2y into y dash equals, the right hand side will simply be 4a into 1, because differentiation of x is 1 and differentiation of a is 0, which effectively tells us that y dash equals 2a divided by y. Correct? Right. Now, once we have got y dash, what we do next is we construct the equation of the tangent as y minus y equals y dash into x minus x. Okay. And this will give us capital Y minus y equals 2a by y into capital X minus small x. Okay. Now, as we did in earlier problem, we'll cross multiply this and rewrite this equation in the form of a into capital X plus b into capital Y plus c equal to 0. Okay, so doing that will give me, yeah, first of all, I'll cross multiply small y, and that will give me yy minus y square equal to, on the right hand side, we have 2a into capital X minus 2a into small x. Right? Now taking all the terms of the left hand side to the right hand side and rewriting will give us 2a into capital X minus y into capital Y equal to, sorry, plus y square minus 2ax equal to 0. So as I mentioned earlier, this term will become small a, and then this term, sorry, yeah, so this term will become b, and this whole term will become c, so that we have p to be equal to, the formula for p is, as mentioned earlier, p equals modulus of c by root of a square plus b square. So accordingly, p will be a modulus of minus 2ax divided by root of, yeah, now a is going to be 2a, that will give me 4a square because we need a square, and then plus b square will give me minus y the whole square, which is y square. So this effectively will give me this as 2ax divided by root of 4a square plus y square. So this is the expression for p. Now once we have got p, what should we do next? We'll have to use this expression and compare this with the given equation, and also use the expression for r square as x square plus y square to obtain the pedal equation. So to do that, what we'll now do is we'll simply substitute y square as 4a into x plus a in this expression and proceed further. Okay, so this will give me 2ax whole divided by root of 4a square, and as I said, y square will be replaced with the right hand side 4ax plus 4a square. Okay. Now this is going to give me right hand side as 2a into x 4 divided by. Have I missed out any term? I'm sorry. I think I went a little wrong with this thing. So as you can see here, this whole thing is c. So basically, I've gone wrong with this c term. I'll rewrite this. So this will be y square minus 2ax. So accordingly, this will be y square minus 2ax. And once again, in this term and in this term, the numerator will change. So now that I have substituted y square as 4ax, 4a into x plus a, the numerator will be 4a into x plus a, that is 4ax plus 4a square minus 2ax. So that this will turn out to be 2ax plus 4a square, right? Divided by the denominator will give me root of 8a square plus 4ax. Now, upon simplification, in this, the numerator, I have a 2a common, and that will be leaving x plus 2a in the numerator. And likewise, in the denominator, I have root of 4a common, and that will again give me x plus 2a. Correct? Now, this upon simplification will give me, as you can see, 4a when it comes out, 4 when it comes out will give me 2, and that 2 will get cancelled off with this 2. And a into x plus 2a is what we have in the numerator. And in the denominator, we have root of a into x plus 2a. And that will ultimately give me root of a into x plus 2a. Right? Now, this is what I have as p. Now what I do is I'll use this expression for p and I'll have to eliminate x. For that, I'll use this expression again, which is r square equal to x square plus y square, and simplify further. Okay. So now I'll use this expression, which is r square equal to x square plus y square. And in this, I'll substitute for y square as, what is y square? Y square is 4a into x plus a, right? So this will be 4a x plus 4a square. Okay. Now this is effectively, as you can see, x square plus 4ax plus 4a square, which is simply x plus 2a the whole square. Okay. Now I'll call this equation as 1, and I'll call this equation as 2, and I can easily now compare 1 and 2, because as you can see in equation 1 we have p equals root of a into x plus 2a, and in the second equation we have r square equal to x plus 2a the whole square. So basically r square is x plus 2a whole square, which implies that r is nothing but x plus 2a. So substituting that in equation 1 will give me p equals root of a into, as I said, x plus 2a will simply be r, so that we have p equals root of a, or squaring on both sides will give us p square equals ar. Now this is the required pedal equation of the curve. Now this is the procedure involved to find out the pedal equation of a Cartesian curve. Of course, whatever procedure that I've taught you now is just one of the methods to do this. There is one alternative method which is also which also works very well. So in that method, what you can simply do is, as you know, finding the pedal equation of polar curve is much easier compared to finding the pedal equation of a Cartesian curve. So given the equation of a curve, what you can directly do is you can rewrite this equation of the curve, which is in Cartesian form, in polar form by substituting x and y, by replacing x and y in terms of p and r. Right? If you can substitute x and y, you can get rid of x and y by bringing in p and r, r and theta, using the expression r equals root of x square plus y square, and theta equals tan inverse of y by x, or vice versa. What we can do is we can use x equals r cos theta and y equals half sine theta in the equation. And once we do that and simplify, we can convert this Cartesian equation into a polar equation. And once we have got the polar equation of the curve, we know what has to be done. We know how to find out the pedal equation of a polar curve. So we can proceed further in that direction and find out the pedal equation by eliminating theta and getting the equation only in terms of P and R. That is one more way of doing it. But this method, what I've taught you just now, is preferred to that method as such, right? So go through these two, go through the solving of these two problems and try to work out more problems, and that will definitely help you. Thank you.